Okay. Okay, good morning everybody. Welcome to ESP32 IoT Workshop. My name is Bin Kang. I'm your today's instructor for this workshop. And we have two helpers who are Jia Peng and Chen Yan standing behind you, who will be giving you assistance in case you need it. This workshop is highly practical. We have not much time for theory and knowledge. So please follow closely, even though you might not understand what's going on behind the scene. And if you fail to follow, it might affect all the afternoon session. So morning session will be talking about the hardware, which you will see right here. And also the software, the Arduino IDE will be using. For this workshop purpose, we'll be using PC rather than your laptops. But for those who bring laptops and you wish to install your own Arduino software, please come to me during break time and we'll do the installation for you so that you can bring the kit home and program on your own. Be mindful that in case you need any assistance, please don't hesitate to stop me or to raise your hand to call the assistant over there, because we don't want you to miss out any details that I'm going to teach today. I want to ask a quick question. How many of you have prior programming knowledge? I know two of you. And maybe you're from data science, so you might have a few. And who else have programming knowledge? I mean experience. Python? 0? And you? Which language? Python.
No, previously. So I experienced using MATLAB.
Oh, MATLAB. Oh, MATLAB is not easy. And who else? Which language do you use? Python. Today we are using Arduino language, which is based on C++. So if you know C++, maybe for some engineering students, you will catch up pretty easily. Right? How many of you have knowledge on the hardware, the Arduino, the ESP, the Raspberry Pi thing? Anyone use it before? No, or no, 0 knowledge. So this kit is perfect for you because you might want to experience it and create something out of the box that you bought with today's workshop. Okay, so let's jump straight right in. Before this, I'm gonna share a Google document to you. Or I might not. Let me check how I'm gonna share the code to you. Okay, I will share a Google document and you guys open it so that whatever code or whatever text I will just put in the Google document and you will just copy from there. So let me see how I do it. And how do you get the link? You might notice that in your email yesterday, that's an email sent it to you by Makerspace. So you should go there and grab your link, right? Grab your Google Sheet, no, Google Word, Google document link. So I'll be doing my office. Okay, do your sign. I'm trying to check your email if you have that. You should receive this yesterday, before the IoT workshop that contains everything you need to know about today's workshop. So I will pasting the Google Drive link here, right? This is the link to the Google document. Okay. Give you some 5 minutes to get the document. Blank. Never save your password on the public computer, please. You may use incognito to log in your Google account. Oops, anyone with the link can view. Alright, so please go to this link. This one? This one is the code. I want the text sometimes. Check your email that contains this document. You should receive it. And please have this Google Doc always open because I'll be updating stuff over here. So you can grab the text that I've written here. To give you some 3 minutes. Got it. Yeah. Hey, did you guys check email yesterday? No.
No.
Ah, before the RD workshop. Okay, refresh. Yeah. This one. Okay. Scroll. This is the link on Google. Okay. This is the link to Google document. Okay. Other. Okay. Please help your neighbors if they are having trouble. We work in the helping each other environment. That's why I put you guys into random seats. 有吗？有哦。Yeah. Walao. Okay. All good? Do you need more time for this? Okay, 2 more minutes maybe. We will start exploring the kit in a short while. So you may take a look and start unboxing the stuff, the plastic bag, the wire, the cable. Done? Done. Japan, okay? All good? So if you ever want to see the code sneak peek or you are impatient of me teaching slow, you can just access the code in the first link. I recommend you not to do that, or you may do that. Okay, so let's start. We'll start to explore our kit today. So this is the kit that you receive. So first we have the board called the ESP32. It's like a small CPU that contains Wi-Fi. Right? It's like your laptop, but it's very small. So this chip is capable of you uploading code onto it, and it runs the code for you. Remember, the name is called ESP32. And next we have some sensors. You will see this flying fish. It's a air pollution sensor. So it detects organic molecules in vapor form. So later we'll be showing you how to use that. And next we have this called DHT. Okay, DHT is in blue color with some wires. And the function is to sense temperature and humidity. So people use it for smart farming, because the plant needs to survive best with certain humidity and temperature, right? So this helps to monitor that, and we'll be using it shortly. And next we have some outputs. For example, these LEDs, 3 colors, the resistor, and also a buzzer. So you shall be playing sounds from this buzzer in the morning session, together to light up some LEDs. Okay. And one of the most important thing is this breadboard, because this is where we will construct our electronic circuit. You have given 2 that you can connect using this. If you notice, you can actually make it like Lego. They connect like this to make it a long breadboard. This is optional because we won't be using all. You'll be using one of it, but you may want to do it for convenience. Okay. Finally, we have some cables. And you'll be given 3 types of cables. And this is the male-to-male cables. I'm sure you know why it is called male-to-male cables. I won't be explaining much about this. You can relate this to biology. So male-to-male, you have this female-to-female. You know the reason why. And finally, male-to-female. Okay. We won't be using female-to-female today, but you might need it in the future, so it's included in the box. Okay, these are called jumper wires. And finally, you have this USB micro. We call this a micro USB type B. So this connects to your ESP32, and this connects to your PC. So you get power from this USB cable. And this also serves as a cable for you to upload the code from your PC to your ESP. Okay. Any questions so far? If not, then I shall ask some questions to you. May I ask what is this called? I don't know the name. Anyone? I forgot the name. What is the name of this board?
ESP31.
31, you sure? Any other answer? I don't trust that person. Daphne? Okay, Daphne say ESP32. Agree? Alright, good. How about this? I won't call the name, but I'm curious, what does it do actually? And why do I need this? What can it do? Any suggestion? Yeah. Yes, and your name is? Adi. Okay. Given a point. And the next is morning, Dr. Irfan. Please take a seat. I shall given. Yep. Please sit next to him because you need guidance on how to get started. It's okay. So sorry, I used it for demo. Okay, last question. What's the name of this thing? Who said that? Did you? Okay, what's your name? Alright, given a point. Good. So now we have understand everything and we can jump straight right in. So sorry, I give taken one of your jumpers. So we're going to construct a circuit that's a simple high school circuit. You might have actually known this, so please do it if you have known this. And for those who just started, we will construct an LED. We just want to light up an LED. So don't look at the screen, look at the whiteboard now. So we are going to construct a simple LED circuit. LED. Recognize that? It's a symbol for LED. Or correct me if I'm wrong, because that's what I remember from high school. Okay. And this is the power supply. The power supply for your ESP32 is 3.3 volt. So we use 3.3 volt for power supply. And as you might have a guess, this is your jumper wires. So you might be wondering, how do you do this given your ESP32, right? And ESP32 actually comes with power supply. It can supply you some power to light up LED, for example. So the positive terminal is called the V3V3, and the negative terminal is called the GND. So this exercise is for you to locate the GND and the 3V3 on your on your ESP32 board. Let me adjust this. Okay, I located some GND on my board. See a few actually. 1, 2, 3. I have 3 GND. And where is my 3V3? It's here. Okay. So take this 1 minute to identify the 3V3 and also the GND on your board. You might want to start unboxing it. Just put it like this. Yeah. Okay. I'm too short for this. Do I have a ruler or something? So that's your ground, right? GND. Okay. And you have one more GND over here. I suppose. And you have one more over there. And you have a 3V3 at the far right corner, which is here, your GND. GND is here, and your 3V3 is over there. Okay. So please select one GND for your circuit, and please use the 3V3. Okay. Good. Anyone failed to identify your kit, your pin number? Yes. GND. And then GND just beside. Okay. Yeah. I know it's a bit too small, but people like small things now, right? Mini laptop, smartphone is always smaller. They expect things to be smaller. Identify. Can you make a guess of what GND means? It's an abbreviation actually.
No.
Wow, you guys are smart. You can. Shall I go back now? All about 3v3. What does it tell you actually? 3 by 3 word. Yes, you earn another point. I forgot your name.
The last one.
Okay, Yong Kang. So we shall start to connect our first ever electronic circuit. As you might have known, your board has actually come with male pins at the back. See this? All the male pins. So how do you connect male pins? You use female cable, right? So take one of your female cable and plug in your male pins. Which pin? Of course, you want to plug in the ground and the 3v3. So the pin below corresponds to the pin above. So don't connect wrongly because you might burn the circuit. Okay. So I'll show you one examples and you should know how to do it. Now, by convention, we use red color for power, blue color or darker color wires for ground, or brighter color for power. I'll be using a red cable for my 3v3 and a black cable for my ground. I mean, feel free to use any color, but for the sake of clarity, you can follow the convention that I've shown you. Okay. Wow, very fast. Okay. So this is how I will connect the wire. It's here. So I'll connect like this, and connect the other one like this. Oh. GND. Okay, good. Which jumper do you use? You use male to female. Because this breadboard is all female. So you need a male end for your female breadboard. You need a female end for your male ESP32. Okay. So how do you use this breadboard actually? Shall I give you some more time? 1 minute maybe. Good. Shall I continue? I'm like a lecturer. Shall I continue? Any question? No. Okay. Please look at whiteboard because I will be showing you how you use a breadboard. So please examine your breadboard and it shall look something like this. There's the plus and minus here, and plus and minus here. And the empty space over here, and all the rows, all the columns. Okay. First of all the columns are connected. So these columns are connected. Connected as if there are 5 holes in a column, and these 5 holes are connected. They are the same thing. For row, the horizontal row are connected. Okay. Connected. You might be wondering, how is it possible? Right? You don't see any, I mean you see holes and holes, but you don't see the connection behind. It's literally behind the connection. If you are brave enough to flip your breadboard to the back side and actually try to get a sneak peek about what's actually happening here. See, this is just a Lego that you can unplug. So they actually connected with by a metal plate. See that? So let me, I mean you don't do it too much, you just peer a little bit and see. You need to put it back at the end. So the reason I say all the rows are connected because they are held by a metal bar. And you know metal is a conductor, so all the holes are conductors. I mean they connected. The same goes to column. So just give a little bit of a sneak peek about the column. See? Oops. And I accidentally broke the sticker, but never mind. So these columns are connected. But two columns, they are not connected. See, there's a mini gap between these two metals. And you know gap is insulator. So these two columns, they don't connect to each other. But along the column, yes, they are held by a metal. So this is how your breadboard is actually constructed. And I have messed around my breadboard. So please give me like a minute to put it back. Okay. So this is the questions. If I connect a wire here and connect the wire here, disconnected. How about if I connect the wire here? Are these two connected?
It's the same way.
No, right? So again, the same goes to this. How about, because you're given two breadboard, the question is, how do you make the whole thing connected? Any idea?
Wire from jump.
Yep, you use a male-to-male jumper. So you put this, connect to here. And since these are connected, and these are connected, and these two are connected with your external wire, so the whole bar is connected, right? So once you put in maybe 3v3, the whole thing becomes a 3v3. And we are going to do this, not this, we're going to do just one board, but we will follow this convention of using the plus as our 3v3 and the minus as our GND. So it's very simple. You plug this, you remember the wire just now that you put in 3v3, you plug in this positive. And the other one you put in the negative. So this means the whole bar is now your ground, and the whole bar is now your 3v3. Good. Give you some 1 minute. You have trouble finding the pin? Please get help from your assistant. Good. Agent, good. Stefani, good. I haven't connected. Good. Can. All good. You are already an expert on this. Join my workshop twice. Good. Okay. Next, let's connect our small leader LED. Okay. Any proposed idea on how do you connect an LED? So your LED should have a leg connects to your 3v3, and the other one connects to your ground, right? Can you identify which is positive, which is a negative LED? So this is your LED. I shall change the focus. You see a little flag in the LED. So the leg with flag is a negative. Okay. And if you touch the LED, the side of the leg, you will see a flat surface. So this is a negative. Automatically, the other side is a positive. Okay. So let me just put it here. You see this? Oops. And I will draw this out. Usually for an LED, it comes with a flag and a pole. And the flag has shorter wire, the pole has a longer wire. And this surface is actually flat compared to this. It's more curvy. Okay, curve. So this is your negative, is your positive. Flat. And the flat. Okay. Did I make a mistake? I hope not. Yep. So that's how you identify the polarity. LED is a diode. Diode has a polarity, right? You shouldn't connect the other way, otherwise it wouldn't light up. So having identified the pole, you can now connect. Well, all these are the positive and all the upper one are negative, right? So why don't you just plug in like this? So you successfully connect the positive to a negative, right? But before you proceed, I shall test. Okay. Might be wondering why it still lights up without blowing up, even though I don't put a resistor. It's because the operating voltage for a red LED is around this 3.3. But if you put more than that, of course it burns. Okay. But to be safe, you might want to put a resistor, but that's homework for you to know how to do it. Okay. So I give you some 1 minute to try and light up your LED. Oh, good question. How do you switch on the ESP32? You switch on by plugging in this cable and also plug the other one to your PC. So it gets constantly 5 volt and 1 amp from your PC.
So the negative terminal is the negative terminal.
Yeah. Boleh. Oh, I think this one actually wrong. But no. Resistor 3.3. Terbalik nggak? Correct, right? Oh, yeah, I know. Let me try it. Okay.
Tadi you makan apa lagi?
Tak boleh. Ke LED 40. So this is your LED. And the other LED. Voltage rating should be okay. I mean, 3.3 is very small. Anyone burn an LED? What? You burn an LED?
Why the red color cannot flash on?
The other one can.
Oh, the other one can.
But the red LED is actually the least voltage one, because red is on a longer wavelength, least power. No, EE, engineering. Okay, use different color if you couldn't do on red color. Oh, I think burn it. Check. You use 3.3. Oh, for certain LEDs, I think the voltage is overload, right? I think so, because I checked her light, right? The red LED, if you notice, right, it has a black color soot come out. Yeah. So for certain LEDs, it's actually different voltage. Now we learn that. Okay, even though it's the same LED, but different voltage rating. So how do you modify this to be a safe circuit? You put a resistor, right? You put a resistor. So I shall take out this LED, and I will put a resistor lah. And for those who have your LED burns, we shall replace for you. I shall replace for you.
What is the purpose of resistor?
Resistor is to limit the current, flow. Otherwise, LED would burn up for certain LEDs. I'm surprised to see that small proportions of LED actually burns, even though we all buy the same product. But yeah. So anyone needs an extra LED? I think you need, right? Yours burned already.
Yeah.
You need? You also need?
Red color.
Red color, huh? I didn't know that different LEDs have different rating, even though same color. I shall replace you later. Okay. So let's modify this circuit and put a resistor. I mean, where is my marker pen? Right? This is my marker pen.
You got.
Oh. So we shall modify this and put a resistor. How do you draw a resistor? Is it this? R. So resistor helps to control the current, so the red LED doesn't burn. So how do you connect actually? Well, I shouldn't put my stuff over here again, because I mean all are connected. So I should make a separate circuit and connect my resistor. So the connection goes like this: positive to a resistor, resistor to a LED, LED positive, LED negative to the ground. Okay. Might be wondering why I don't put a plus minus for resistor. Because the resistor is unpolarized, so it works both ways. Okay, if you put one as a positive, the other one will be a negative. So let's do that. I will now use a male-to-male cable. Do you have a male-to-male cable? And connects a positive to one of the columns. And the other male-to-male cable, I shall connect a resistor to the other column. So then I put my LED on the same column. And connects my LED back to my negative. Okay. Do you see the diagram clearly? I shall. Okay, good now. So let me repeat that. A male to male from your positive to a column. The same column connects your resistor to another column. So the other end of the resistor, the same column, you put in your LED, positive end. And the other end of positive LED, you put in another column. And finally, the negative ends of the LED, the same column you connect to your ground. Okay, seeing those confused faces, I shall draw a diagram for you. So this is your breadboard. This is your 3v3 from your ESP32. This is your GND. Okay. So this one connects to one of the column here. So this whole column becomes your 3v3. Okay. And take one of the column and put a resistor. And the other resistor, put in another column. So this another column, put in your LED. And the other end of LED, make it put in the adjacent, the neighboring column. And then this one connects back to your ground. Good. Just now, put in an LED. Wait, I want that now. I shall give you first. Red color. I find replacement. Ken, boleh ya? You need a tanya. Apa tu? Not lighting up. You nak pakai circuit ni ke? So you take one male cable. One cautious you should be doing is when you are connecting your circuit, right? Please disconnect your USB cable. So you cucuk satu ni dekat empty column, and then take one resistor, sambung ni another column. So take one LED and sambung like this, and the final column take another cable and connect. Oh, you need a Mấy tầng nữa. Let me try it. Wait now. Can capture. Can. You can check the specification on the internet. What's the voltage for red LED?
Standard one, the voltage.
But from experiment, it's not standard, right? So I think it has a range.
Okay.
There's a range for that. Can ah? 可以啊。可以。Can. Can. Ini double net. How about I take your circuit and I use my PC. So you share first lah. I don't know why it doesn't work.
Because of the USB.
I don't know. I try to change to my ESP32.
Oh, you just plug your PC.
Like this. I plug in my ESP32. This is my ground. This is my connect. Positive to positive, and then to negative. Wait. This one. LED problem. LED issue. Okay. For those who burn LED or who miss some LEDs, let me know later and we can collect and replace for you. Okay. Wow, this is cool. So what's your voltage for red LED? Yeah. So we shall now start to do some real electronics. I mean, just now was a experiment. Okay. I was saying that this goes to your 3v3, right? But actually, in the end, you want to control it from your ESP32. So, how do you make it on and off while you're in this circuit? I mean, you can go and unplug the cable and plug it back, but we don't want to do that. Eventually, we want to control with the internet. Okay. So what we will do is, instead of connect to a 3v3, we connect to the other pin. And for this, the other pin, I shall show you the pinout for the ESP32. So this is the details of all the pins you have in your ESP32. 3v3 is the one just now we used, as well as ground. But we will unplug this 3v3 and put in the other pins. Now, if I say 3v3, it means power supply, right? So for all the other pins that you see numbers, they are all power supply, but their default is off. So if you connect this, if you unplug this and connect to the other number, you don't see your LED lights up. You have to program it to on the, for example, D4. You have to on the D4, so it becomes your 3v3 and lights up with LED. So we're going to do that, and now we want to control the LED on and off, right? So let's unplug this 3v3. I mean, you don't unplug the 3v3 from this board. Let me show you a circuit. So what you should do is, I mean, all of this circuit done, right, with working results, with LED lights up. Anyone whose LED couldn't light up? All good? So what I should do is I know that this one comes from my 3v3. So what I should do is to unplug this so that my LED receives no power whatsoever from my 3v3 anymore. Okay. And instead of drawing from 3v3, I shall draw from my D4. So try locate D4 in your LED board. It's around here. You see that? It's around here. D4. It's beside D2. Some of you have the name G on your board. It's the same thing. G4 and D4. Okay. So you take one wire, connects to one end of the resistor, and connects the other end to your D4. D4. Okay. 3v3 and ground still keep untouched. But now, my LED is not powered by my 3v3 anymore. My LED is now powered by my D4. So with this, you need another male to female cable, because your D4 is also a male end. Okay. So from this drawing, I now connect not to my 3v3, remember, but to my D4. And this D4, you can program to on it or to off it. Okay, good. So I give you 1 minute to modify the circuit. And plug in your USB to your PC. You don't see any results. You don't see any results because you haven't yet on the D4. Going on the D4, so it's blank. Okay. All good. You successfully modify your circuit. So now I give you 1 minute to clean up your table because we're gonna do some coding. Any questions you would like to ask? What's a red LED voltage? The red LED typically drops around 1.7 to 2 volts. Oh, between 1.8 and 3.3. Okay. I'm surprised to see some still survive. Shall we do some coding?
Yeah.
All good. Let me check. Okay. Kita belum check. This you connect to the D4. Yes. I mean you can have, but they are not using it right now. But you need it later. Don't take out your 3v3 and ground because you need it after. Okay? Why Not connection.
Okay.
Oh, already I don't see that. Sorry. I thought everything in the box. Can boleh semua boleh. Good.
Now,
I shall connect this to your V4 because we are not coming from 3 So this one originally is to power your LED. That's from the 3 And now we shall plug and get a cable. And put it in your V4. V4 is distributed. But you should follow the names in here. Good. Shall we continue? So let's do some coding. Raise your hand if you have not done the circuit yet. Shall I continue? Good. Coding is when you do the magic to control your LED. So let's open this, the Arduino IDE 2.2.1. Already have that in your PC. I think it's open on every PC already. But just search for Arduino and you will see the code. So the one with the, sorry. You can do the search. Good. Check if all of the Arduino. Good. All good. Arduino good. Okay. All good, Kenyan? All good, huh? The first code we will write is, do you see this white setup and loop in your IDE? Any guess on what it does?
To run the code.
I mean, what's the difference between setup and loop?
The loop, it loops the code repeatedly.
And the setup?
Just to run it once.
Okay. What's your name? You get 1 point.
It's Taiwan.
Taiwan, my name list is missing. So you don't get points. Until I found the name list. But okay, I will record in my mind. As he mentioned, yes, the setup is to run once because it's written there. So you're getting free answer. The loop is to run repeatedly. What kind of things that we want to run once? These are the stuff which you might not understand or might not believe, but try just to follow. So the setup is we want to specify the pinMode of my number 4 to be an output. Okay. So I'm telling the ESP say, hey, my pin 4 is an output, and don't make it an input. Okay. As this is a C++ based language, everything is case sensitive. So the capital M, remember, don't make it smaller. And also the semicolon in the back. And don't forget to put it. If you successfully written this, you will see the pinMode change its color. Because it's a famous function which gives a special color for the function itself. Alright, done. And next we will do the while loop. We are going to on the D4, remember? So I shall do digital write to my D4, and I want it to be high. Okay, I want it to be high. Hey, yung online. Okay. Alright, after this, remember this semicolon, you must put it on each line the code you write. So I'm saying that, let's give it a comment. Comment means you do a double slash and say, I'm showing you what's the function of code. So everything comes after command, comes after double slash, would not be executed by the code. So it's just for your own reading purpose. Let's on the D4 pin to light up LED. I think it's a comment that you can put like whatever you want. Let's put another comment lah. Just to prove that this code is your code. This code is written by, and you replace with your name here. Okay. If copy, pay me, pay out. Yeah, that's a comment. So those who use my code should pay me a Mexican. Okay. So done this, we are ready to on the D4 and to run the code. First, let's select the board that we use. So here, it's a select board. Click that. You'll see a lot of ports might be on your PC. You do not know which one is connected to your ESP32. So a quick tip is you choose select other board and port. And choose the one with the USB. I have two with USB, so I have to guess lah. I'm guessing computer A. And the board that we use is a WROOM ESP32 module. So this little thing actually many manufacturers produce. So we use the manufacturer called the room. So choose this, choose the one with USB and click OK. All good? Follow? All good, Japang? Click OK and you can upload. See the arrow to the right arrow? Upload. If you have failed to upload, means you are not choosing the correct COM port. You shall connect your ESP to PC when you upload, otherwise your code will go nowhere.
Sir,
Yeah.
what is it by 4?
4 is your pin number 4 because you connect to D4.
How to count the pin?
It's written on your.
So D4 means pin number 4.
Yep. D5 means pin number 5.
Okay. D26 pin 26.
Pin 26, yeah.
So
So it takes a while to compile and to upload. Maybe my PC is just slow. Anyone successfully light up an LED? Have you plugged in? Yep. Such a WROM. Oh, I know why. Because this one has got no installation. Can you help to install the driver CP2102? So now LED is now on. See? Okay. Anyone successfully on the LED? On.
No.
Anyone fail to on the LED? Cannot. She connect to D4. D4 to this, this one to ground, right? And this one to ground. This one to ground. Change LED. No, impossible. Change LED. Make sure your LED is on, because you program it to on.
Oh, okay. So this one is button base.
I don't know, I have to check that. Check. For those who couldn't light out your LED, try to change to different color. And during lunchtime, we will do a checkout. LED medical checkup. Alright, all good. So now let's do some fancy stuff. let's do blinking. So I'm gonna on LED for 1 second and then off for 1 second and do it repeatedly. And we use the code called delay 1000. Means I stop the ESP32 from doing anything for 1000 milliseconds. Okay? Can I? Let me see. And you shall complete the code lah. So how do you turn off an LED? Low. So you earn a point. Yep. Let me complete the code first, and then I'll go into individual. Digital 4 low, turn off and the LED, and then delay for 1000. Okay, so you shall see the LED now blinking. Yes, what happened? Maybe I will wait for it to double. Oh, then try to close it. Open again. Try to fix that paper. Blinking. Not blinking. Oh, you did not successfully upload this. So, thanks. Let's go. For those who have done right, my challenge is to make it blink differently. So change the delay number to make it blink differently. Okay, do some fancy stuff like 2 LED blinking alternate. Boleh. You search WROOM. Tak ada ke? Oh, so tak install. You type ESP32. Install. Nanti tunggu dia install, lepas tu search lagi. Can siapa tahu? Boleh. Still the prior issue. Okay. Some drivers yesterday installed but uninstalled. Alright.
Uninstall as what?
At least this one has got no installation. No serial data received. Oh, you choose the one with USB. Oh, already processing. Okay, then should work. Okay, shall I proceed?
Yeah.
Good. Nah. Share first lah. Nanti. Okay. So let me change the delay speed to 200. Shall blink faster then. Okay. See, my LED is now blinking faster, which you can tell from the video, and my mouse is blocking. Okay. I'll give you a challenge to do. So this is the code for the LED, right? And if you see your kit, you have a active buzzer. Buzzer means the device that makes sounds when you power it. The principle is entirely the same. It's exactly the same as LED. When you on it, it gives you sound. The LED, when you on, it gives you light. Right? So what we are gonna do now is try to find your buzzer. Can you locate your buzzer? A buzzer looks like this. The black color thing is your buzzer. Okay. Might have a sticker on top that you have to peel off. A white sticker. See that white sticker? Peel off.
There is no positive and negative terminal label.
There is. There is. The plus.
Oh, okay.
Just like an LED, a buzzer is polarized. So it has a positive, has a negative. How do you locate the positive side of a buzzer? The leg is the same length. So check this on the top. After you peel off sticker, you see a plus button. And you see a plus label. Oh, I could see the buzzer sound already. See that? This one. So this plus label means the leg is a positive. Okay, leg is positive. So I want you to do is to connect the buzzer the same way as you connect the LED. But maybe now you don't need a resistor anymore. You can just still put resistor, safety. So I shall duplicate this diagram. And this is now my buzzer. What's a symbol of a buzzer? Okay, just put a circle and write buzzer.
Okay.
Yeah. Not the correct electronic symbol, but yep, you got a point. You try to connect to your 3v3 and GND, you should hear the sound. If you don't hear the sound, your buzzer is broken. So connect the same way as your LED and check if the buzzer gives you a sound.
If I remove the resistor, can I hear the louder sound?
You should. Anyone got the sound from your buzzer already? Yep. Oh, that's rather noisy. Oh, okay. Okay. I hope there's no alarm system. We're gonna code an alarm system though, if you have time. So first try to make your buzzer work. You should now know how to connect your buzzer because it's the same as your LED. Can that PC? Or we change PC? ESP32 issue. Got backup or not? Can ah? No sound. 差 negative， positive 没有差。差去 positive， 不然差一个 resistor 了，就跟 LED 一样。Yes? Okay. Successful? Successful your buzzer? Is it sound?
Yeah, just now.
Sound. Top performance row. Does it work? ESP32. The working replacement. This one, the USB is not there. Okay, we identify the issue. Go buzzer. Buzzer. Help your each other, help the neighbor. What's the name? Ini yang nak isolate. And to replace you and another. All good?
I have one question.
Yep.
If my electronic component requires more than 3.3 volts for the supply,
There's a 5 volt on your ESP32 that you can supply.
it can supply 5
You can
volts.
supply 5 volt. Alternatively, you can use a battery. If it needs more than 5 lah,
But the battery connect to the
no, connect to the component.
not directly.
One example is motor. Servo motor requires like 12 volt. So if you want to connect via the ESP, it has to be from your power supply. Okay, so let's all good. Buzzer sound. Anyone has their buzzer not functioning? Can Adrian? Can So now we are doing the same thing again. We want to control the buzzer to on and off. We don't want it to be noisy all the time. So let's disconnect this 3v3 and connect to pin D5. The pin D5. And you should expect what to do lah. You just change the wire and connect a female to D5. Okay. All good. Now okay. Good. Let me connect mine. This and a resistor. And this to ground. Damn noisy. If you don't hear sound, might be your resistance is too high. I try connect without resistor and it works.
Yes, sir. Sir, what's
Yep.
Arduino sound?
Suddenly no sound.
Yeah.
I can't burn again. This one too. Because by default all the pins are off. Okay, I've done connecting my buzzer. So my LED is now connects to D4. My buzzer connects to D5. Okay. 全部可以吗？手把手歌啊对，哪个两手背？手背，set processing 啊。Sorry 啊，刚刚跟你 share 一次。Okay. Now we will code the buzzer just like we code the LED. Digital write, delay, pinMode. Okay. So let's go to our code and say, alright, my buzzer is also a output. Let me also do my buzzer to blink. What's the sound equivalent for blink? To make sound every 1 second. Digital write 5 high and digital write 5 low. I already heard the program running. Who did it? You did it. That's a blinking of the buzzer. Okay. So this code tells you that your buzzer should light up as well as your LED blinking. So the buzzer sounds follow your LED blinking. And recognize this is actually your alarm system. Okay? Your alarm system works exactly this way. The light ons and the sound, the buzzer ons. Okay? What happened is too noisy. You just unplug the cable, so it becomes not noisy. Yep. Oh, the code. Shall I show you the code? Let me just send the code in the Google Drive, like a Google document, so you can copy. Turn off buzzer. Turn off buzzer. Turn on buzzer.
Okay. So first, actually what we're doing with the nozzle and the LED are the same thing. Just like we have to replace the LED with the buzzer. So we are going to do a cross buzzer. So let's check. Why you plug in the inside one?
So I give you like 2 minutes to try. One challenge, yes. Alright.
So,
E5 not working? You did not specify E5 to be might not work because you did not specify the pin 5 to be output as well. This is crucial to make sure that you specify the pin mode to be an output. Okay. Ming. Yep. No sound. You connect. Oh, the code failed to run. Yes. Did not do the semicolon. Yep. Room on. 你要开一个叫做 Create Agent， 这个你开了就有啊，10笔，然后你 refresh 一下。我累了，都没有拔掉 speaker。Okay, please unconnect your buzzer. Too noisy. Okay, good. I still hear some buzzer. Can you disconnect your buzzer? You just unplug one of the pin and disconnect. Okay. I will show you what does it look like if you fail uploading the code. Everything here will be red color. So I'll show you one example. The most common mistake is I did not put a semicolon and I do uploading. So this means that your code did not get uploaded to your ESP32.
So this is the pin 1,
Okay.
pin 5 actually.
And you will get clue on where you did wrong. This case,
Okay, so like select
Here.
this one.
so put a semicolon there. When it successfully upload the code, that looks like a blinking of another sound. See? Maybe a 300 millisecond blinking. So if it's successfully uploaded, you will see this percentage till the 100%. Can哦，你要用那个 Firefox， 看才可以用。
这个是
看也可以。啊。
看这个
online 是可以的吧？其实效果我会教啊，你 figure out 一下哦，然后我再。Okay, you might have your buzzer connected back and make some noise.
Why yours is not lighting out? Tapi boleh mana?
Yep. Tell me Taiji. Cannot.
Boleh kan? Masih oh.
Connecting buzzer.
Dia buat pasal dia tak ada. Dia connect pasal ada semua. So positif kena connect dengan D4 dia dengan G4 satu. Ya, ground kena connect dengan plus new yang flat color ni walaupun dia inside. So connect dia Ini pada sini, pada sini, pada sini. Ini balik pada actually it's the same thing.
All good, Adrian. Okay.
Baik, tapi I tak share karakter tim tu saya ada ada.
You should be audio here.
下面开气。
加这个
没有上。Good question. Someone asked. Jay, my friend asked about if these two columns are connected. Are they connected?
No.
The only way you can check is to peel off sticker and see lah. But the answer is they are not connected. But you can peel off sticker to see.
oh ada.
Which I will do it for you, because
Tapi I tak check nama dia punya pasal bunyi slogan.
see. Look at that. There's a gap in between these two, so they are not connected. And I've successfully broke my breadboard. No worries. Good. Okay, can we have buzzer to disconnect? Sorry. Okay. Alright. I shall write down all the pins that we are using. Please don't remove the connection, because this carries forward to your afternoon session. So first we have the LED to D4, and we have the buzzer to D5. And next we will have the MQ135 to
D6.
No, we do it D32. I mean, you can do any other pins, but let's standardize it, right? And the other one is DHT to D33. So how do you connect these two? We have done this, and we are now doing this. So take out your MQ7, MQ135. It looks like this. Okay. Is anyone missing a pollution sensor? Your MQ135? You all have that. Guess I got one extra, I don't know. Okay. So when you look at this, you check your flying fish, that's your air pollution sensor that detects your organic molecules in vapor form. It has 4 pins. One is a VCC, one is a GND, one is a DO, and one is the NO, AO. Okay, that's good. We're gonna use VCC, GND, and AO0. AO, actually is A0, A0. We're not using the D0 here. So any questions on the pin?
What is A0?
A0 is analog output,
DO is
digital output. So we use analog output. This flying fish specifically operates on 5 volt. So how do you get 5 volt from your ESP32? Is here. V in. So V in is your 5 volt. Or for some of your board, it might say 5V. Anyone having 5V on your board? Not the V in? all are V in, all V in. Okay. So this V in is supplying 5 volt to whatever things you connect, and we're gonna need 5 volt for this flying fish. So the connection goes like this. This VCC connects to your V in. This GND, as you might have guessed, connect to your ground. And this A0 connects to your D32. Let me draw it out for you. Your MQ7. VCC. Oh, too small. VCC, GND, D32. There are 2 ways you can do it. This is a female end. Sorry. This is a male end. My goodness. And your ESP is also the male end. So you can use a female to female cable to do it. I wouldn't suggest that way since we have a breadboard here. I might as well just connect this to my breadboard. And I do something like this. So this becomes what? So I have successfully just connect the sensor to my breadboard, and these 4 columns will correspond to my 4 pins here. So do that. I mean, you can do either way. I would suggest the second way. Again. Okay. Connect this. So one goes to my A0. Where is my A0? A0 goes to my D32. GND goes to my ground. Oops. Need a male cable for this. VCC goes to my V-in. V-in. Okay. And once connected, you shall see your sensor to light up like this. If it doesn't light up, means you have something wrong with your connection. Good. It's warm because it's heating up. Okay. Anyone bringing a sanitizer? I need a sanitizer. hand sanitizer? Got. Any sanitizer? Okay. Oh, any more sanitizer? Spray version. Then we try using this. Some works, the non-spray one. Oh, you got a spray one? Thank you, thank you. This sanitizer will trigger your sensor to give you data reading because it has alcohol inside. Alcohol is an organic molecule. So your sensor triggers by organic molecules. Oh, good. Anyone have any issue with the sensor connection? Good? Adrian, good? Okay. So now let's go to code and we shall do some coding on reading our sensor data. I don't want to disturb this, so I shall make a new code. I'll make a new code. File, new sketch. Give it some time to load up. Okay, you might want to save this. File, save. I mean save to your desktop or anywhere. LED and buzzer. Yes. Have to be no space when you save the code. LED and buzzer. Okay, once you save, you can minimize it because we are not using it at the moment. The next we create a new sketch, and this is a brand new sketch. So let's put some pinMode 32 to be, is it input or output? Should it be input or output? Should be input.
Ground also need to connect. Ground also need to connect the ground, or just be at the
Yes, we have to connect ground.
ground also need to connect.
Yeah, connect ground to your common ground. Connect V in to your VCC. Leave the DO disconnect and connect your A0 to your D32. The answer is input. Okay, input. And we will do a serial connection. Not the cereal that you eat in your breakfast, but the SERIAL. Serial. Serial is a command that enables your ESP32 to talk to your Arduino. Sorry, to talk to your PC. I keep saying Arduino because I used to do that more. So serial is a connection between your PC and also your ESP32. And the connection, the bridge, is a USB cable as you would expect. So that's called a serial connection. That's why when you press this, it says serial port. Okay, serial port. So we're gonna begin the communication between these two by typing serial.begin. Give it a speed, let's say 115200. Okay, good. Any question? No one asked why 115200.
Why?
It's a baud rate, it's a speed of the connection. How fast you want the connection to be. You can choose the other baud rate, you can choose the other number. I will encourage to put this as default because there's a default, there's a common way people do it. But after that, I shall show you that there are a lot of different baud rates that you can choose. So why do I should say Let's make a variable with the data type integer. You know what's an integer?
Yeah.
Integer is anything that's not a fraction or decimal. 1, 2, 3, 0, -5. All these are integer. So I'm calling a variable called integer. Let's give it a name called a sensor reading. And then I say, hey, I'm gonna read my sensor reading and put it here. So sensor reading equals to analog read. I will read analogly from my pin 32 and store it in my sensor reading. And finally, I'm gonna print it out on my PC. And to make it happen, I need a serial connection. I have to say serial.print. I don't want to just print out continuously. I want to print by line. So each print gives me a new line. So I say print line, ln. ln is a line. Print what? Of course, print my sensor reading. I don't want to let it print too soon. Let's give it a 100 millisecond delay. That's about 0.1 second. Then after done, I shall upload. If successful, I will put it in the Google Doc and you can copy. But I suggest you to write it down your own. Done uploading. The way that you can check the data is at the serial monitor here. So you're like you're looking into conversations of other people. You're gossip. So let's gossip what the PC and Arduino, the ESP are doing. Let's click serial monitor on the upper right. So I'm now gossiping about what they're talking about, and these are the sensor values that I get. And by right, when I spray, see, when I spray, I get higher reading because this has alcohol, I think. Sanitizer.
So this one will be in the background.
Yeah.
See, look at that. Or you can just breathe on your sensor because your breath has got an organic molecule. 200. Or you can fart on this. Your fart got ammonia. I don't know, you can try lah. So anyone needs this, you can take it from the table and try. When you need that link, the Google document, you can get it from here, which is at your email. Your email contains these documents, right? These documents, and you scroll to the bottom, you will see this Google Doc. You click that, it brings you to this live documents here. Okay. I think you breathe out carbon dioxide so that it detects. I might be wrong, but that's my hypothesis. Kan? Link ah. Ini N0 DHT D32对不对？然后这个白色是 V in 对不对？然后这个 ground 是 GND。
Sir,
Yep.
what is mean by ball?
Which one?
BAUT.
What is a baud rate? The speed I was talking about.
Speed means how fast it can detect, is it?
The speed means the speed they communicate. It's not the detection speed.
Oh.
The speed between communications of PC and the ESP. There are a lot of things, a lot of speed you can choose.
So the higher, the bigger the number,
Should be the faster. But you can try. You see this 20, 2000, and 20 million. Delay 1000, sensor reading, analogRead, sensor reading, pin32 input, serial begin.
Square them.
Try my sensor 咯。按这个。我 try 你的 sensor 咯。这是没有，奇怪。换这个 D32 玩意。换这个 D32 玩意。Anyone successfully not getting reading? What did I talk about? Not successfully getting reading. Why? Always zero.
Always zero.
All zero. All zero. Reset. All zero, you try to change the D32 cable. The wire connects to D32. Still zero 啊，要动。哇，你这个没有亮。这个 need 5 watt， 你要渐低一点。Underground 有 underground。Still zero. Anyone else getting zero? How many of you getting zero? The rest not getting. The rest getting values lah. What? Thousand something.
Yeah. Same on zero, zero,
try to disconnect the other cables and see.
Oh, I think molto belle.
Zero again. You connect D32 right? 有过两个，学认力啊。Oh, you don't spray to the sensor, you spray on the table. So it evaporates and detected by the sensor.
Oh yeah.
Good?
No, 0.
Still getting 0. Let's try to put a 20-second delay in the beginning. Because this sensor needs to warm up for 20 seconds. Let's just say delay.
Kita CO2 kita kira.
So shall wait 20 seconds, then it start getting value. Try again and see. My turn getting 0. Still 0. You spray through the Okay guys, please don't spray into the sensor. I mean you can, but it's not good. You prefer to spray on the table, let it vaporize, and detect by your sensor. Place your sensor near the place on the table which you spray. Then analogRead 32 input. 更奇怪。It's on ground right？ 白色是 ground， 红色是 A， 灰色是 B。又是买很多份了。not round. Still 0. 你放 float 带 float boleh ya? Sama. AD.我差题了，7分。 你 try 过了。Anyone getting non-zero value? Or all zero value? Okay.
The value is going down. It's just going back to 0 after spraying. What does it mean? Now is 60 something. How we can interpret? So what are the values, different values, the meaning of?
Actually, there's a resistor inside, and the value represents the voltage that it's a voltage divider circuit. So we are getting the voltage from the potential difference in the sensor that tells us the resistance of the sensor.
Okay. So this sensor is a fusion sensor, right?
This sensor, it detects organic molecules like CO2, like your alcohol, and the alcohol molecules will trigger the resistance to be changed, to change.
Can we also get, for example, so it should be some ranges for each one of these molecules, right? So if it is in this range, what is the percentage of CO2?
That's a better sensor for that, but this is very basic. 135 man. So this one. Detail. So that's a working principle. You can work it out in the data sheet, but the idea here is it detects the change in the concentrations of organic molecule in the ambient air, and then the resistance change as well as the voltage.
Can we also do, for example, if this is a resolution sensor, it can say it is good or bad, right? It can say it is now pollution is good or bad, right?
But pollution doesn't mean it's only organic molecule causing it, right? Can be other non-organic molecules.
Yeah.
So I think it gives you an estimation, but not the exact pollution index. You still need a bunch of different sensors for different types of molecules. They combine the data, and you do some calculations that shows you the connection.
What is the example?
So there's some 1000 value, 0 value, and normal kinds of value, right? Which I think could be part of the working temperature of this MQ sensor. By right, you should wait 20 seconds before taking data. I mean, your data after 20 seconds should be good. But in the case of your data not getting value even after 20 seconds, I think might be a problem with the sensor that has to be calibrated. Which I would suggest us to let's connect it first, because we need it for the afternoon session, and we can move on to the next sensor, which is the DHT. 我会还你我的，你的。你是肌肉还是有东西？这样慢慢变肌肉啊。Okay. So I suggest to just leave it. I will try to look for a solution, right? And then next we connect this DHT sensor. So DHT sensor is for temperature and humidity, right? And it's this. So do you see this in your kit? That's your DHT sensor. So the connection is the same. You have the plus, minus, and the out. The plus goes to your, this can be your V3, doesn't have to be 5 watt. And the negative goes to your ground. The out goes to your D33. Let me draw out the sensor. So plus, minus, out. PV3, GND, and also D33. Okay. So you can connect. Meanwhile, I look for a solution for the MQ135. Let me try to change it. Yeah. Pin 32. Where's my 32? Okay. So the connection is the same as the MQ sensor. You have this. So this goes to ground. This goes to 5 watt. And the middle one goes to your D33. Okay. Okay. So I give you like 3 minutes to connect your DHT circuit.
Sir,
Yep.
what is meant by DAT?
DHT.
DHT. Yeah. DAT or DHT?
DHT. DHT11. Digital humidity and temperature sensor. It's a blue color one, it's a 11. It's a white color one, it's the 22. It's more expensive. Today we use the 11. Okay. Oh, okay. Not okay leh. I don't know why the sensor not working. Okay ah. Này cái.这个 connect D33。connect yeah, DHT. Your DHT might be different from mine. You might have the DHT as the out DHT. So the DHT shall connect to your D33 line. Okay? And the ground and the 3v3.
I have one question.
Yep.
What is the difference between you connect with 3v3 and V input? Oh, one is used 3 watt, one is used.
One is used 3 watt, one is used 5 watt.
Okay.
Okay.
My value still get 0.
For the air sensor.
The DHT.
DHT we haven't coded yet.
Oh.
Yeah. DHT code differently than the air sensor. So now we are going to code the DHT. So to code the DHT, I have the code for you. But basically we'll be using a library called a DHT Library. Okay. So we shall move on for the air sensor and go to DHT. The DHT sensor uses a library called the DHT.h library from the Adafruit. So you can click this library book, the book logo, and you search for DHT. So look for this DHT sensor library by Adafruit. Choose the latest version and install it. You should also install this Adafruit Unify sensor. So just click install all. A library means somebody has done the code for us. So we just use their code for our sensor reading. So with that, let's create a new sketch. You can save this as in desktop. MQ135. So get a new sketch. So I shall give you like 2 minutes to ready for the coding. Oh, sensor is 0. Weird.
In the coding, right? Sometimes we put input, sometimes we put output. So what is the difference?
Output means you are supplying power to that pin. So you want a power buzzer and a power LED, you should use output.
Output is directly supply the power.
Yeah.
The input will collect the output.
Input means we collect the power.
We collect the power.
So we are collecting the voltage from the sensor. Usually for sensors we use input. For the output like servo model, like LED, like buzzer, we use output. Because they need power. Okay? So we shall have in every time we use a library, right? All good with the code. Shall I start the coding? Every time we use a library, we will include a library. Okay, include a DHT.h. So I'll be following the code I've written yesterday, which is here. It's called the tutorial basics and the DHT reading. So you can download this and open. Meanwhile, I'll be writing for you lah, so you can follow along. Breadboard starting. Okay. Let's just follow this. Include a library, it's called a DHT.h. And we're gonna define the DHT that we use. Define DHT. We are using the blue color, which is the 11. Okay, this is the 11. So see this DHT type to be DHT11. Then we define the pin that we are using. So today we use the pin 33. Then we create an object. It's called a DHT object. And the details is known as the object-oriented programming. But for today's purpose, we are not discussing that. DHT, specify the pin, specify the type. Yep. Don't forget the semicolon. So we're now using the library called DHT.h, which is this. Okay. So again, we are reading sensor data from the ESP32. We're gonna do the serial begin and also serial print. This is just an indication that we are reading data. So reading DHT sensor data. Okay. And we're going to begin the DHT reading process. We just write DHT.begin. The DHT library comes with a few functions that we can use. So one example function is called DHT.read temperature. And as you would expect, the other one is called DHT.read humidity. Okay, this one. DHT.read humidity. And we'll take this function that's reading the humidity, ambient temperature, and we store it in a variable called, let's say, humidity. So let's give it a data type. This time we're gonna use float. Float means a decimal value. Okay, float humidity equals to humidifier. Humidity equals to DHT.read humidity. We do the same for the temperature. Float temperature equals DHT.read temperature. Okay. Now the other function you can use is the compute H heat index. That means it takes into account the humidity and temperature and calculate for you what's the feeling temperature, which we are not going to do that for this purpose, and we are just going to print out the results. Now, just now we were just printing out a single value, and that's okay. How do we print two values then? Right. So we can construct a beautiful sentence to print out our value. First we print out the text called humidity. Put a colon here. Then we print out the reading, that's the humidity. The difference between these two is, first I'm literally printing out the word humidity, the colon, space, right? And the second line, the line 20, is I'm printing out the value that I've gotten from the humidity sensor. I continue print temperature, and finally I print with a line my temperature. And the reason we are doing this is we make a line, says humidity is this, temperature should be this, and in the end let's print a new line to prepare for the next data. After that I'm gonna put delay for 2 seconds, because this sensor is a pretty slow sensor, so you need a few seconds for it to get data. You can make it beautiful by putting Celsius, temperature, Celsius. Try to get the symbol of this from Google, or if you know how to type it out, you can do that. Humidity is in percentage. I should have some space before the temperature so that it looks nice and neat. And finally, I will outlook. So again, I will put this code to the Google document. Print was not declared in this code because I forgot something. This is not Python. Python you can just type print. But I have to put serial.print. No one corrects me that. Then do the same for all. And then run. Yeah, I actually haven't connected my DHT yet. I shall do that now. So I shall leave the code here. If non-zero is obtained, you will see the NaN. That's called not a number. Okay? Because I haven't connected my DHT. Okay? If I connect, I should get data. Let me connect. Three v3, yeah. Can?
The temperature Celsius, how you get that superscript?
I copy from my code, but you can search. You can search online. Celsius symbol. Unicode, then you can get it. So you just copy this and put it in your copy and paste. Okay. Yes. Just copy from one of the results here. Or just write degrees Celsius. Okay, degrees Celsius, it works. Okay. Pin 33. So now I'm getting my value, and you should get your value. So if you're curious about how they wrote this library, right? You can press your control. Press control, click this DHT.h. So it brings you to the library which is all the complicated stuff that I don't understand. But this is how you write code for the others to use. It's called a library. Can? Boleh.
Different sensor is different library, is it?
Most sensors don't need library, but this one need library. Accelerometer need library. Gyroscope also need library. Sensors that don't require library are the light dependent sensor and the MQ sensor.
This one is declared DHT.
Oh, because you did not install the library. Did you install the library? No. I think you put the wrong symbol, it should be down.
Can you bring just
Sensor okay.
You can modify the reading by rubbing your hand and touch the sensor, so you should get a higher temperature. Yep. No value. Wow, this room is cool. Oh, Ricky, maybe because it's a function. Anyone fail to get data? I just copied from my Google. Expected declaration before. Why? Oh, you shouldn't put the image. Delete. Okay, try again.
啊，没有灯出来不是还可以做吗？可以做，这应该没问题。哎，你是有什么都没有灯？
Whoa. Why is it clear? 3v3 哦，你介绍反正是 ground 而已。介绍。完了。Try again. So, we have one example of inverting the polarity. So if the polarity is invert, the DHT sensor will get very, very hot. So if you sense something wrong, please unplug immediately, because you might invert the polarity already. If normal conditions, the DHT sensor shouldn't feel super hot. 我怕是死掉了，你的 sensor。Use my sensor see。因为你插头发。ini 3v3 ya. Ini 33 ini to round right. 有没有？有啊哦。看了没有 replacement 给你。So this sensor is burned. This sensor is burned because the polarity invert. So make sure to check what's going on your board, because each board is different configuration. Might be written VCC. Yeah, this one DHT, GND, right? Don't confuse GND, VCC. VCC goes to 3v3. GND goes to GND. DHT goes to D33. I'm like rapping. Get 0 lah. Give it some rest, maybe can revive. Anyone else burn the sensor? You burn the sensor? And then because you were not getting data. Not getting. Who else get NN? 1, 2, 3, 4. The rest get value. Oh, okay. It doesn't get. This connects to 3 volts, and this GND is to the ground, and this is D33. Try to increase the delay. Make it 5 seconds. Try to increase delay to 5 seconds. We are calling the function known as read humidity from the library called DHT.
Okay. Read humidity
It's a function.
is a function for the library.
Function from library. The details you can check in the library. How they code the read humidity. Okay. Set. Can I try to connect? And see. I'm getting values.
You were getting any.
No, now I'm getting value. So I'm afraid that might be the cable though. I'm trying to change the cable. Change the wire. Sorry. Polarity. Easy to register.
没有value。
It was the cable. Cable. Now I'm getting results. I'm checking the cable.
Okay. This one might have words because just now you don't see the light coming out. That means you might be wrong a few minutes before. So yeah, second example of inverse polarity lah. Can still at the end. Scroll down. Can you unplug and put it in my I don't. No, the DHT. Okay, I put it in. Here I'm getting value. So can you check your cable? Okay. And let me teach you how to use a multimeter to check your cable connection. So let's give me one example. This one. You want to check if your cable is working fine. You can turn this into a connection mode. You make two probes, one to the end, the other one to the other end. Can you help me? Connect.
Ada bunyi. Problem ada.
Need a working example. Yeah, yeah. So, guys, if the wire is working fine, you will hear the beep coming from your multimeter once you connect two ends of your wire. So I will show you the mode. The mode is this. Okay, this mode. The connectivity mode that looks like a Wi-Fi. So if you want to check, then you should use a multimeter to check. Okay, thanks. So anyone still not getting data from your DHT? All good? All good, ah? Then shall we? Are we waiting for our lunch to arrive? So we shall go for a break, and the afternoon session will be all about Internet of Things. Let me just show you a sneak peek on the things that we are going to do in the afternoon. So this is the thing. Wait, So I now have my full circuits with me. That contains a buzzer, DHT, MQ135 sensor, and also the LED. And I shall control all these things from my phone, which is now connected to the Wi-Fi. So this is a thing we'll be doing in the afternoon. I mean, you can feel free to explore during your lunchtime, but we'll do it in the afternoon. Arduino IoT Cloud. So this is the app which we use. And the website that we use is called the IoT Cloud. That's this IoT Cloud. Okay. So hopefully it works. Let me refresh and show you one example. Show you this example. So as you can see, when I switch on, the buzzer turns on, so as the LED. Let me look at this LED. Maybe you try. I'm not cheating, and he is holding the phone that he's controlling my Arduino, my ESP32 devices. Trying to on the LED. So see this LED on as well as it follows what the user does. And this is what we do in the afternoon. I shall prove to you that when I go out to my hometown, it still works because it runs over the internet. Let's see if I can do that during lunchtime. If I go and buy some tea live, and I can do it there. But this is basically what we're doing in the afternoon session. Okay. So I'm sure all of you have your accounts ready for the IoT Cloud. Did you? Did you do your IoT Cloud account? I hope today the server is good. Okay lah, I will try this morning, should be good. Okay. So now let's take some time to arrange and clean our hardware, because we'll be using the same hardware for the afternoon session. So yeah, I will be working on cleaning up the hardware. So make sure you have all things on your breadboard. That's your MQ, that's your buzzer, that's your DHT, and that's your LED. So shall we go for lunch, Jeshari? Lunch ready. So where do they take? Outside? Yeah. And they eat here or can eat? And we'll have actually we are scheduled for 1 and 45 minutes. Sorry, 1.5 hour break. But I wish to do more this afternoon. So if we can, we come back at 1 p.m. Is that okay? Right. So meanwhile, I'll be just sitting here to troubleshoot the sensor. If you have any questions, feel free to come and ask. Yep. Don't afraid of interrupt me eating lunch. And I think good. The lunch is outside. You can take it in the table outside. Yeah. So I'll see you at 1 p.m. Thanks. Okay, we're starting. So I suppose you have the connection ready. Your breadboard must have all the sensors and the MQ sensors. So you should have MQ sensors, the DHT sensor, and a buzzer and an LED on your breadboard. And make sure the MQ sensor is light on as well as the DHT sensor. Those are indicators which means they are functioning. Okay. So now we are going to do some cool stuff over the internet. Not this Spotify, but we're going to read the data from our sensors through the cloud connects to the internet, as well as to control the switch and also the LED and the buzzer from the internet. Okay. So please give me a moment. I will now draw a bit on how it is done through the internet. Basically, Arduino is kind enough. Arduino is actually a startup that has grown over the years. So the Arduino Uno, the famous board that you heard about, is by Arduino. They also do this cloud thing, which users can send data to each other and also to receive data from the cloud. So basically, you have a cloud storage. This is provided by the Arduino for the Arduino cloud. I have a question. What else cloud you have heard of? iCloud. Exactly, iCloud, right? iCloud means you store your photo into the iCloud. Maybe you retrieve from your MacBook. Any other clouds that you have? For Android, you have a Google Photo. Those are clouds. You can access your photo from the internet. YouTube, Facebook, those are all the clouds that they use to store data. Okay. This time we use the Arduino cloud, which we store value from our sensor and we retrieve from our PC. So what happens is this cloud is huge. I mean, we are not the only ones using the cloud, right? So you take a small piece of a cloud, you call it a space. And this space is yours. Okay, I have a space called my cloud. It's a misleading name, but it's my cloud. Okay, so under this space you can have things. One thing is one project. So in the thing you can put code, you can associate device and so on. We call things. Okay. So he's getting my juice coffee. One person is entitled for two things. So you can do two projects on your space in the Arduino cloud. I mean, if you pay monthly for subscription, you can have more things. Today we'll use one thing. Means we're gonna have one project deploy on our space and store in the Arduino cloud. So this is our thing. So inside this thing, there are three things that you do, which is you write code, you associate device, and finally you receive data. Receive data. Okay, and we're gonna do all of this today. So please remember all these terms because you will see that a lot later. Okay. So this is an example of the products which can control the buzzer, the switch, and also receiving values. So this cloud also connects to your PC, so that your PC could retrieve data from the cloud. So it's connected via the internet. And this cloud also connects to your ESP32. Okay, ESP32. The reason why you can do that is there's a Wi-Fi module in ESP32, which we are going to use to connect to the internet here. So that it connects to the Arduino cloud and send data. Okay? We're gonna do this step by step, starting from creating a thing. We create an account already, and we are going to create a thing. So, I will start from scratch, although I have a result already. So let me use another account. Sign up. Sign in. Google. You should have signed your account by now. If you haven't, you please do it now. Okay. My password is, how should I tell you? Okay. Don't save, and I have to. Thank you. Can I use my phone for the my phone? Oh. The order just got paid.
Yeah.
I think this is the font. This is the Spanish. Mine.
You also do the Spanish?
Yeah, I did my code. Okay, good. So I now log into my Google, which logs into my Arduino cloud. You should do that now on your own so that you get an Arduino IoT cloud. Yep.
I take a picture on your photo card.
Okay. So the first thing you will see is a blank thing. It's called this create your first thing. Remember, we are going to create our thing. That's our project. Okay, go ahead and create it. Maybe I'll give you 2 minutes to reach this page. I'm gonna check. Boleh. Loading, all of it. Already got your pitch. If you're wondering which way to go, I shall paste the link into your Google Drive, a Google document. This. Okay. So go to here and create your account. Give you more like 2 minutes. Enjoy. Just. Boleh ya? Boleh. Okay. Assistant. IoT clouds already. Yeah, Okay, good. All good. All good. All good. All good. So we shall proceed to create a thing. Right? Where did my carry go? You do a two-step verification. Maybe 1 more minute. Just. One second. Okay. So now let's create thing. We create a button. We press the button create thing. And we're going to name our project as what you like. ESP32. Done? Just a name, you can name it whatever you like. IoT Workshop, the best. Just a name. And now we start to associate device. We are going to put our ESP32 onto this thing that we create in the cloud. So far, any issue? Anyone needs an assistant? All good? And we do select device. We do set up new device. We do a third-party device. Let me repeat. We do third-party device because we're not using the Arduino board. We do ESP32. That's your name. We do a room model. Room. Okay. We press continue. Give it a name. I mean any name as you like. Galaxy, no iPhone. Apple. Whatever name that you like. I like Galaxy. Next. This is crucial. Please see this. You need the secret key for your verification later on to prove that it's your device. So please download the PDF that contains your secret key. Or copy and paste the secret key on your phone or whatever. Save. Continue. Congratulations, you're all set. You should reach this page, which I'm gonna give you like 2 minutes. Download now. Boleh. Apa? Wah, 4 hours ni. Boleh ya, boleh semua boleh. Siapa yang tak boleh? All good. All good.
All good? All good. Okay.
Good. Alright. Please help your neighbors because I couldn't go through all. Okay. Next thing we'll do is to connect our ESP32 to the Wi-Fi. So we are going to do it in this network page. So click the configure. Now you can now choose to use your own data connection. I would suggest to use this Wi-Fi instead. That's a TP-Link _ 9B20. The Wi-Fi is here. TP-Link 9B20. Password I will show it to you. It's the 15985095. Okay. Secret key is the text, the code you get it from your PDF, which is this. You don't copy exactly the same because we all have different secret code. Can I zoom in? Okay. Yeah. So that's a Wi-Fi name and that's your password. Alright, all good? All good, then we shall proceed. Please save. She shall see your Wi-Fi name and password successfully configured here. The next thing we'll do is to create variables. Means we are going to choose what we are doing with this ESP32. So click create variable. Should I proceed or should I wait? We can proceed. Huh? So there are 4 things we can control. Where's my marker pen? We have 4 things to control. That's our LED, that's our buzzer, that's our sensor reading. So for LED and buzzer, we are going to see the state of the condition. Is it on or is it off? So we write the name LED state and we write the name buzzer state. We don't just want to see, but we also want to control, right? How many states could an LED have? On and off. So 2 states. Any variables to recommend? What's the variable type that gives you only 2 values? Computer science. Boolean. Not Boolean. Boolean. So Boolean is a type of variable, just like your integer and your float. That only gives you true or false. Yes. We only need these 2 values. Because your LED is only on or off. What else could it be, right? True or false? I mean, integer, as you may have known, is the minus infinity minus infinity to infinity, but it's a whole number. How do you write whole number in R? Don't care lah. This is mathematician way of writing. And float is everything lah. Everything negative infinity to infinity. Actually, it's not infinity, right? It's a limit, but the limit is too large to be useful for our purpose. So float is everything that contains decimal. Integer is just whole number, and Boolean is only true or false, 0 or 1. Recall back, you write high and low, right? Just now. That's also a Boolean. First, it can be only high and low. It couldn't be like very high or very low. So high and low is also a boolean in the Arduino system. And also today we're going to use boolean for our LED state. So let's write LED state here. And we select the variable type to be boolean. The bool LED state. Bool LED state. Since we don't just want to read but to also control the LED, we put read and write. Okay. Update policy we do on change. So whenever we change the value, the ESP is gonna reflect of the change. So we choose add variable. So now we have our first variable. Let's do a second. It's the same, but we make it buzzer. Because as we have done, buzzer is also only on and off. Buzzer state. It's also a boolean. Read and write on change add variable. Next, we do this. Can you suggest me a variable for MQ135? What's the reading? What's the type of the sensor reading that we use just now? Just now was like 0, right? And then a few hundreds and 1,000.
Integer.
Integer. Yes, we use integer for this. So do that. Add. Let's say MQ reading. So we choose integer number here. And we choose read only. Any reason why we don't choose write? Any suggestion? Can you control the MQ reading? No. So we can only receive. So we choose read. Okay, read only. Of course, you can choose read and write, but it will do nothing on the right part. So we just choose read. To simplify our code. Finally, what's the suitable variable for DHT11? Just now we were reading around 37.7 Celsius. Float, yes. FLOAT. So let's choose add. Name is the DHT reading. Be careful at DHT there are two values. Do we choose temperature or humidity? I mean we can choose both, why not? So temperature reading. Select variable type, it's float. Read only. So for this demo purpose, I'm gonna just read from the temperature. I can easily expand it and easily modify into. I'm making it read the humidity as well. Just do add variables and so on. I will leave it like this. Give you around 1 minute to reach this progress. So after done, you can try to go to sketch. And good thing, code has been written for you. Right, code has been written for you. I try to read this and understand, but I'm gonna explain it later. So just now we were doing everything on the local, right? We're doing everything on this Arduino. Oh, not this Arduino, but the other Arduino. So I now want you to save all the previous codes and exit this Arduino program, because we are going fully on cloud in this afternoon. We might come back on this later, but save your code and make sure everything is closed for the Arduino program just now, because you don't want to interrupt your cloud code, right? Otherwise you couldn't upload it. Here, I give you some 2 minutes. Make sure you have no Arduino program open on your PC, except this Firefox. Oh, I did not mention, did I? For those who use Google Chrome or Microsoft Edge, please switch to Firefox. I mean, you have already your account, you can just log in. Because unless you want to try if it works later, but from my experience yesterday, only Firefox works for this. But you can try lah, and then you can switch after this. Okay, good. Shall I proceed? So now, go to your start menu and search for Create Agent. Okay. You have something called the Arduino Create Agent installed on the PC. You should click to run it. See, I have 2 Create Agent done, run for me. You should only have 1 lah, so I'm gonna click 1. Okay. So, what the Create Agent does is to connect your Firefox to your PC, to your ESP32, so that you can send data. Otherwise, all the codes will be on Firefox. It wouldn't come down to your ESP. So you need that as a bridge, as a link bridge to connect to. So after you have the Create Agent successfully run, you should be able to select your port. For me, COM number 8. For you, might be something else. As you should raise hand if you don't see anything here. Do you see something? Okay. Good. One more time on.
I lost.
Okay, lost ah? Everything lost. Let me get lost again and try to explain. So first of all, when you have all the Arduino IDE open, close that. Close everything that you did this morning. You can save it, you can choose not to save it, but please close. So you shouldn't have the program running right now on your PC. Second, please go to this start menu and search for Create Agent. Found it? Start menu. And click to run it. How do you prove? How do you know that if it's running? You click this hidden icons here. Should be around. Should have a field running on the background. Okay. I will show you what happens if you don't have this running. You will see this no associated device found. So you couldn't talk to your ESP without that Create Agent. So you must have the Create Agent running on your PC. After that, you might do a refresh. You don't have to, just give it a few seconds. You can now select your port. Just like how you select ports this morning. It's the same. Good. I choose COM8 as this ESP32 VRoom VM module. So anyone successfully not found your device? All found? Okay. Yeah. Wait. Yeah. Any assistance needed? All good? So now we're going to modify some code. Modify some code here, which you will now apply the knowledge you learned this morning to apply the code, to modify the code here. So first of all, let's specify our pin to be an output. It's the same. So go to line 21, this void setup. So after this serial begin, you should write. Okay, this you have to follow closely, because it's easy to get lost. PinMode for output. What else is an output? Anyone? Which pin is an output? One more pin we need to specify. Yep, pin 5. PinMode 5 output. No, by default, this assumes all the pins are input. So for the input pins, we don't do anything here, right? Only for the output that we specify. So these two lines are new. Good, shall I? The next is DHT. Remember DHT, we have some extra things to do, right? I will show you the example of what to do, and then we will learn how to modify this code. So this is the code for our DHT this morning. Oops. Come on. So you wanna, not this. You first wanna copy these 3 lines to put it at line 20. Under this include thing properties.h. Can anyone tell me what the line 19 means? What does it mean by include thing properties.h? Any idea? Remember the library we talked about this morning? Isn't this look like reading a library known as thing properties? So it's the same as the reading library from DHT. So copy these 3 lines and paste it here, because we need this in DHT reading. And as you would expect, also copy this line and put it underneath. Okay. And next, we put this line, DHT.begin here, after this PinMode 5 output. We are now learning to modify internet's code to become our code. Sounds like assignment, you modify others' answer to become your answer. But not that straightforward. Good, I shall leave this to you for 2 minutes. All good? Shall I proceed? Shall I wait for another 1 minute? So, next, let's go to this loop. What happened? So there's a line already written here, it's called the Arduino cloud.update. It means every loop it updates the value onto your dashboard. The dashboard means this. This is called the dashboard. So every time it runs this for you to upload to update the data. So we just leave this on unchanged. So first, let's do the DHT reading here. So we will do temperature only. So do this, copy this float temperature DHT.read temperature here. Okay. Wow, this is highly difficult. But recall that we have already specified our variable for our temp reading, right? Our temperature. So instead of using a new variable, we are just gonna use the variable that we defined. That's the temp reading. Since it has already been defined, we don't have to define again. So I will edit this to become temp reading. I mean, if you put on, if you give it a different name, you're gonna follow your name. So this temp reading is exactly the text that I defined just now in the add variable 10 minutes ago. Good. Next, we also read from our MQ sensor. So how do you read from MQ sensor? Let's go back to see our code before. This. Sensor reading, right? Okay. So this is to read from our MQ sensor. This is to read from our DHT sensor. Again, recall that we have already declared a variable for this way beforehand. That's the MQ reading. So we don't create a new variable called sensor reading again. That's useless. We will just change it to MQ reading. And we are done with this code. So what it does is, for each loop, update the data, get the new data from your sensor, update it to your Arduino cloud, read the new sensor, update your Arduino cloud, read the new sensor, and do it like for everyone. Should give you like 2 minutes to make sure you return the right code. And I will also do all the copy and paste to put in your Google documents here. Okay. One more minute. Try to help each other. Couldn't reach all of you. Try. Can. Okay. Good. We are not done with the code. You might not see any results because we have not uploaded it. Right, let's proceed for the other two, which is the LED and the buzzer. This is a bit tricky because we don't just get the value, but we also change the value. So if you scroll down, it's already been given what you should do when the LED state has changed. So go to this void or the LED state change function here. So this tells you that whatever you write in the code, it will be executed once you change the switch, once you press the button. Okay. So what do we do in this function block? We turn on LED, right? We turn on LED depends on the state. If it's on, you're on. If it's off, be off. Okay. So let's do if you study computer science or basic programming, you will know the if-else statement. So we will do an if-else statement states if my LED state is is true, then what do? Digital write. I do digital write for high. Okay. Else I do digital write low. Yes, low. So we literally make this into our code and it works. If LED state equals to true, digital write for high. Else, digital write for low. Be careful on which line I put the semicolon, which line I didn't. There are two lines I didn't put a semicolon. And to make it more tidy, you can put like a few space or a tab and make it good looking. Good. What do you do on the buzzer state change? Any idea?
Just copy and paste.
Again?
Just copy and paste it. Like I already state.
Just copy and paste. No change.
Just the 4 to 1.
Yes, it's right. Just copy and paste the code here and change the 4 into 5. Because it's the same. The buzzer state is off, is low, is true, we switch on the buzzer. If it's not, we switch off. The way to switch on and off buzzer is the same as the way to light and dim the LED. So I will do a lazy way of copy, Control C and Control V. So this I switch to 5. Remember we are using D5 for our buzzer. Okay. Should be good right now. That should be your first IoT device. Someone pointed out that how come you are using LED state for buzzer state change?
Sir,
Yep.
for the if else rules, right? So it doesn't matter if one got tab or not.
Doesn't matter. If it's a Python, it matters a lot. The C++ then don't care. This is wrong because you didn't change the buzzer state.
Oh.
Means it follows your LED state to control your buzzer, which you can do, but not the proper way. So let's switch to buzzer state. And if all good, press the holy button, verify and upload. And this takes a way longer time than your local Arduino. Because it's from cloud, remember? It's from the internet. So give it some time. And give it some more time. Okay. So meanwhile, you can use your phone and go and download the apps that can control your LED. So the app is called the IoT Cloud. I'm not sure if iPhone user can do that. Ada. Okay, lor. So you go to your Play Store, your App Store, or your Huawei Store and download this IoT Cloud. This. So the author is an Arduino. The author is Arduino. You don't download the other apps, might be unauthorized. So download this, and we will use this to control our LED. My code failed to upload. Is your code successfully uploaded?
Not yet, not yet.
I don't think you will be successful upload. Fail, right? Success? Ah? What? Okay, wait. So let's learn how to debug. Expect a semicolon before serial, so I know what went wrong. Didn't put a semicolon. Did I? Let's check which line. Line is on line 16, I think. Check line 16. Did I put a semicolon? Ah, I accidentally pressed a 3, which I shouldn't have to. Delete. Troubleshooting skill is an important skill to know what went wrong in your code. So, although I feel embarrassed, but learning process. Hope you don't mind. Who else got failed uploading? You should successfully upload. Who has uploaded successfully? I sound like a Bluetooth device connected successfully. Oh, 1, 2, 3. Might be. Mine is. What did it say? Oh, 没有放 space. DHT pin space 33. Sounds like a balloon, what? Broken alarm. Uploading, yes! See, it takes a bit slower than
Screw it.
huh? Okay. Which one? This one or this one? I shall copy this code and put in Google Docs, so you can copy and paste, which I don't recommend. Okay, go ahead. So once we have done this, should see your ESP32 goes crazy, keep shining lights because it's connecting to the internet. So that comes rather randomly. Now we can start to play around with the IoT. Go to this and choose the dashboard. Okay. Click Build Dashboard. Give it a name called, I don't know, My Smart Home. Okay. This is where you see and control all the devices. Oh, let me finish this, then I'll go to troubleshoot. Okay. This is for those who have successfully run your code. Add. We have 4 things to add. LED buzzer, MQ, DHT. So first we add a switch for our LED. And the most important thing is to link the variable that connects to your ESP. So we click this, we choose the LED state, we choose link variable. And we do the same for buzzer, which is also a switch. Name it buzzer. Link variable, that's the buzzer state. Link variable, done. So by now you should be able to control your device, which I will now go and troubleshoot. So you should know what to do for the next two variables. Yeah. What happened? Yeah, the temp reading, the MQ reading, the button stick in LED state. Which is the one that you read there? So it should be the same. Should be the same. While was not declared in school. Sequence did not follow this. So you request time reading. So you also use this the time reading instead of DHT temperature. You change the name here. Or you can change the name there, but I suggest you change. Yeah. Also the MQ reading, I don't think the same. No, I think if we go to setup, we use the DHT temp reading. I think which is the small letter. Whatever it's a case sensitive. Yeah.
Yeah.
Yep. Here. Just
Will this thing explode if we do some mistake?
What kind of mistake you were making?
Maybe the voltage is too high or what?
You remember the first session we did mistake? And then some LED explode.
Explode, I mean.
Oh, home not home, but you will see some soot coming out.
Okay. So actually it's not dangerous. You don't get electric shock.
It's just 5 volts. I don't think you will get anything.
Okay. You never tried before, right?
I've never had an experience of live damage.
Okay.
So it's considered very safe.
Because you open your Arduino IDE, interrupting. Boleh control.
Anything changes on the breadboard, make sure you unplug the circuit to USB.
Yeah.
You're off your oil.
Check the code. Check code.
Cậu ơi.
Chỉnh. Workshop. Tekan tu je. Sketch. Turun. Kalau too high, kalau low, force low. Yang ni positif sama 3.3 volt kan? And then this D4. Okay, I know why. Because your circuit macam tu. I saw a fun, interesting thing. If you connect your LED to D4 and 3V3, means you don't connect to ground. your state will be inward. Your state will be inward. High means you turn on the LED. Low means you turn on the LED. So what you can do is to change this into ground. Then you solve the issue. But this is an interesting effect. Normally we connect to ground, right? Issue.
IoT.
Oh, see, after is capital T. Maybe
The Kamiya. Who else need troubleshooting? And what's the error?
I think it's maybe because have you checked whether it
On LED state change.
I think maybe instead probably
Which one? For MQ reading, memang read already.
Yeah.
It's just the LED state in the screen and right. The larger state in the screen and right. And then on LED state change. LED capital. Is your on LED state change capital. I'm gonna try making it capital. Oh, we suggest to not use it. It's better to use all small. Let me know next Do you want to use all small letters? Or one way is to check the press control. MQ and DHT. You can see one even like the view. Now we're going to
全部都是4500千。
See, you will miss, you will be an explorer.
超时就是说
Yes.
Nó là theo cái đó.
I think that
E5.
I think that's a good one.
Ground.
I don't want it.
Rồi có thể bên nhìn. Nhìn cái
Now successful. Yeah. Yeah. See, you use LED stick. Yeah, we want to buy this stick. What it? Wow. Sama. Sometimes just circle. Alright, any more troubleshooting? Wi-Fi password could be wrong if you couldn't make it work. So make sure you use the
Just remove that by using the sensor.
Okay.
The sensor reading.
Sensor we haven't started. So we are now working on it.
The reading.
Okay. Wow. All good. Turns out we have more issues. Temperature reading and MQ reading we haven't started doing. Right? And we'll do it in a short while once we have at once. I haven't started mine. Yep. Ni betul. Ini sambung kau kan? Apa saja? Nah, kita terbalik tulisan dia. Jangan terbalik tak? Kan? don't inverse your polarity or buzzer, because yep. Yes, but you need a different code. If you have time, you can do that. Or we can do that. Oh, when you change the network, have you upload the code again? You should upload the code again so that the new password gets into this. Yeah, you do again.
Or verify on
You click this in last one.
The battery,
Oh, that's the right card.
MQ reading.
Okay.
Switch.
If I want to switch your buzzer off. My God. So now we do the rest so that you can read sensor data. Go back to your thing. Click. Find your sketch. Find your sketch. Oh, actually, we have done the code, so you don't. We can straight to the dashboard. My smart home. So this one we will click. You see, you are now in the viewing mode. So you click the edit mode. We add something called a value. So let's make it a name called the MQ reading. And we link a variable, it's a MQ reading variable. Link it. Done. And we do the same for the temperature. Okay. My EHT is broken, so I have no value, but if yours looking good, you should have value. Need the lighter. Where's my lighter? Oh, it's all. 去找把子。Lighter 嘞 ？Where's my lighter? I put it somewhere. Lighter. I put on the table just now. But the one just now? Takkan I buat hilang. No, you give it to me kan, so I put it somewhere. Here we go. On. See? Whoa. Right. Got because I got the gas ma. Oh. Methane. Somehow very not sensitive. I went 0. Very not sensitive.
My one always at 600.
Try. I should warn you that this is B not 8. Because we have 2 examples of putting it wrong. 9B. Boy.
The DT leg is the P is small or big.
Big. What else? Not bad.
Why the temperature won't change on?
The temperature change every 3 sets of reading.
3 sets of
Because this sensor is super slow.
It's because of sensor problem.
The sensor is slow. Unless you give me some time.
Reset means how many seconds?
6.
需要4000多一个才。
Way slow sensor. You,
Because of
我觉得5000多。
we set in the coding or what?
no, this sensor is memang slow.
Oh, it's because of sensor.
Yeah. So repeat again. This is a sensor. This is very sensitive to your MQ reading because it's a methane CH4, so organic. Okay, try for MQ.
我放那个 resistor 上面2小时我收益。
我已经放好。我放后我的 LED 就没有。
我 LED 也是有 resistor。
你放2段。
A challenge is to put humidity lah. See if you can do it. Add a humidity value. Not sensitive. Well, wire issue.
Already.
But it's not. Is it keep getting to 0? Change wire lor. Or troubleshoot. Very sensitive.
Boleh nampak juga masa saya tengok macam ni.
Yeah, which one? The second. Yeah, add humidity. See if you Shall I add a humidity? Let's try to add humidity. Mine couldn't work anymore. Good, all good. So the way to add a humidity is first go back to your thing. You do everything in your thing, remember? Thing. So click this. And let's add a variable called the humidity. And remember, humidity is in percentage, so let's fix it at the integer. Humidity. We do read only. Add variable. So you don't just add a variable here, you also need to do some coding. Let's go back to Sketch. And we add another line over here. Humidity equals to DHT.read humidity. And I would like to check if the function is correct. Read humidity, okay? And I can upload again. Humidity. So you can see it's very easy to add on things. You can add on like a motor, you can add on fan, you can add on smart home, light, LED, sensor, anything. Okay. Okay. Do my experiment again. FKT. Okay, what is哎呀，雷莫，喂 ，wrong account 啊！哎，delete 的 no 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 no。What? Troubleshooting. Wait ah. What? Yep. Okay, while working on your troubleshooting, I should prove that this works not just locally. So how to prove? I've already have my Google Meet and you can see my phone. So I will go out and go far away from you and try to control. See my face? You go with me, yeah? We go downstairs. Otherwise, it proof. No.
Wi-Fi
No Wi-Fi, internet, cloud, man. I can go my hometown and still do it. See? Okay. So give me 5 minutes. We are now outside. They still work. Let me share my screen. Different locations and different Wi-Fi. Still works, right? I hope it still works and you can see the results. If you cannot see the results, please approach my table. Go to my table and see the LED controlled by me on with your eyes and a buzzer also. Okay? Yeah. I think that's the end of day one. I shall go back now.
The thing is
Okay. Did it work? Serious? No, it worked. It should work. No what? Serious? Not lying? Serious, not lying? Serious. Serious?
We can find
Impossible because I still get the data from my phone. Didn't work.
both buzzer and LED.
Not lying. Are serious?
Serious lah.
Just the two switch one not working.
You don't see the LED lights up.
You see. Now open also can. Okay.
Just now I was still looking at this and I received my MQ reading.
MQ only.
Try it again.
See, this temperature is off. Maybe my device off.
Ah, is it this one? Yeah. Unfortunately, you don't have permission to view this dashboard. It's my own dashboard. So. Hey, it works now.
Buzzer? Buzzer. Upload it.
I shouldn't go out again, but I will use my data connection to prove that I'm not using this Wi-Fi. Oh, I ran the meeting. So I use your hotspot. Your hotspot. Stay on.
Go down.
No, don't go down. My I should. I must prove to you that it works. Okay. Okay. Buzzer. Works. You go down and do. I trust you. We are not doing video call. Okay. Although we do not know where he is going, but he should be away from this room for at least 50 meters. More than that, more than the range of this room Wi-Fi. And I should prove that you still see this changing without me controlling. Let's see. See? I'm not controlling stuff and it works. So I hope there's enough evidence that you should appreciate and keep continue doing this, so that it's a cool stuff to work. Yep. Yeah. Sometimes it works. It didn't work for me too. I will change. It says ID. That's the ID for the Wi-Fi. You see the Wi-Fi here? You mean the TP link? No, that's the Wi-Fi. The name of the Wi-Fi is. Yes, you should do the change. So just change this to your own Wi-Fi and you upload again. Secret key is the same. Any troubleshooting?
The display. My display.
Display. Why is he not coming back?
It's improving.
Thank you, it works. Did you put grip on T or N? Because you can write on it. So you should make a setup. You should MQ reading run. You read on it. Thank you. Face issue when I went down, didn't work. Any more troubleshooting? Did it work just now? I think it's just not connected. Oh, you're using 8 GBE.
Oh.
Okay, we have 3 examples of the wrong SSID. So B, not 8. Why? Why, please? Oh my goodness. Let me change it. Where's my marker pen? I lost my marker pen. Oh. Maybe it's too late to change, but B. Is it good enough? And then you tell me this is all 0 or 0.
20.
Theta.
0 or 0. Okay. So in your home, you can change it to your home Wi-Fi. This is the Wi-Fi provided here. So I shall introduce you what other stuff you can play with. One good example is a slider.
How to add more LED?
Add more LED.
Yeah. Can we connect parallel? No, not parallel. I mean in series.
Do you want to connect? Do you want to control all the LED at the same time, or you want to separate it?
At the same time.
So both LEDs switch on and off.
Yeah.
You do parallel.
Parallel.
Parallel means you get the same voltage. Okay. There's another platform that I would wish to introduce you. It's called ThingSpeed. ThingSpeak. The ThingSpeed is more to research based because you get all the historical data from ThingSpeed. So I should show you how it looks like, and we can make some example. So this is ThingSpeed. Let me create my account and go in. So this will be the things, right? All the readings, historical reading I captured from yesterday. This is extremely useful if you have a lab that constantly collect data and you went home and you go home, but you're a workaholic, so you still need your data. So you can check online your data in lab. I mean, this you get a real life data, but how about the historical data? So you can use ThingSpeed to do that lah. But I should also show you that you can download all the data from here. Example, I'm downloading the MQ reading and the temperature reading. So I can download, goes to my email, you can download from my email. Why don't you try do that? Download the data and check from your email. So let me go to my email. See, so you receive a data called the Arduino IoT Cloud History Data. Download. Open with. Okay. So given 2, let me open the temperature reading. See, it's very good if you want to do a research. I have only one data for temperature. So for MQ reading, I have a lot. See all the time. Okay. You want to do analysis on your data?
Yeah.
Offline, further do your research plot graph, This is very helpful. Okay.
This is every second.
This is every update.
Every
So
second.
if you set update on every second, it gives you every second.
Can we like interval every 1 hour?
Yep. The way you set interval is going to this your code. Where's my code? See? You can put a delay before you do the update. So these lines of code updates your data to the cloud. So you can, okay, I need a 2-second delay before every update. Or if you work the math, you'll do a 1 hour delay. So that's 1,000 at 1 second times 60 minutes. Times 60 seconds, that gives you 1 minute. And times the 60 minutes, that gives you 1 hour. So this is in millisecond. 1,000 millisecond times 60 is 1 hour. So you can adjust your update frequency based on this. But I would say, why not get as many data as you can, and then you can do more analysis, right? So that's one way. Okay. So let me introduce you think speed. Entirely different, but it has its own charm from this Arduino cloud. So since we have some time for this, or do you want to explore other stuff? Before this, let me ask if you have any questions.
I want to know how to analyze the data.
Analyze data.
Yeah, how to like draw the graph.
You can plot graph on your Excel. You can
In the think speed you can do it.
think speed, it plots graph for you automatically.
How we do this actually in the think speed?
And this one I'm gonna show you in a while. But even the Arduino cloud, you can add a graph, you know. Chart. So you also link variable to your, let's say, MQ reading. So it keeps getting the data and plots a graph for you. MQ graph. Live. So you can do 1 hour, can do it every day, and you can do live. It's extremely helpful for research. Okay. Example, I now use lighter to excite my MQ reading, and should see a bump in the value. Let's see. See? Oh my god. So that's how you analyze the data. The good thing is everything is free. So, and it's just that you can only have 2 projects on this platform, unless you pay for subscription. But why not you have multiple accounts, right? You have Gmail, Hotmail, Yahoo. Then you have 6 projects. Okay. I think it's very good that it does what ThinkSpeed do. I should still introduce you ThinkSpeed, but maybe we won't go into the application. Okay. Yep.
If we download the data, then we give us in the Excel form, is it?
In a CSV, yeah, Excel. You can use Python to analyze. Yeah, MATLAB, Python. Python is very good for analyzing data. Question?
5 reading here. Then if I download all the 5, I will have 5 different
5 different files.
file, but I compile it.
You cannot compile here. You have to download and compile yourself using Python. Okay. All good? Any more question? No question. So since you have the kit with you, right? Why don't we do a challenge on? Do your own IoT thing back home and show us your results. Maybe you can make some cool website to publish all your results. Who knows, right? Who knows, right? So yep, that's the idea of the IoT. So let's work on ThinkSpeed. ThinkSpeed is an alternative to our IoT cloud. The good thing about ThinkSpeed is you don't have to code everything on this. You can code locally and access on cloud. Okay. So are we done with this all? I could have an additional workshop with a follow-up on how to use all of this, but it requires you to fully understand the basics today lah. So the workshop may be not open for absolute beginner. We just start directly from at once, but that's another story. Let's work on ThinkSpeed. Do you know that you can actually control the LED brightness? Like what you say, you use the slider to control LED brightness. You wanna do that?
You can use dimmer also. There is a dimming one.
Here,
Yeah.
you choose the value. The code is slightly complicated, right? Slightly complicated, but given the time, we shall work it out lah. So let's play around with this. So now you should close, because we are done with this, right? Close everything. Close, not save. And let's bring out our good old friend, the Arduino IDE.
For the dimmer light, so I have to buy the Arduino accessories, right? But I cannot buy the Philips or Xiaomi.
Oh, you're talking about controlling Philips Hue.
Philips that you can control with mobile phones. In fact, can I control it with this Arduino board? I have to buy the receiver, transmitter receiver for dimming those part for the Arduino part.
Today we are doing the fundamental. I mean, Philips Hue has been done. The Philips company has coded everything and make it into app for you. So of course, you should be able to code it yourself. You don't download the Philips apps lah. And today I'm showing you that you don't have to buy a Philips Hue to do this. You can control an original lamp using, but of course you couldn't control the brightness. But LED you can. The thing that we control for smartphone is called a relay. I don't think you have relay in your board, but if you're interested, I will show you what a relay looks like. So this is a relay. Relay. So this is a relay. Relay means you're controlling high power device with a low power device like the ESP32. So my last project was a smart fan, and I put a sensor. So if someone goes into my room, the fan will on and scare that person. No. It was for me because I keep forgetting to switch off the fan. So I'm doing that to automatically switch off fan whenever I pass through the door. I use something called a motion sensor. A motion sensor looks like this. So this sensor's infrared. We emit infrared, right? So we pass through, the data change, and my fan turns on. So the way I do it is I connect this to my LED, actually to my ESP32, and I connect this. So I connect this to my ESP32, and the other side connects to my fan. How did I do that? You know the fan comes with the plug, right? So I disconnect the plug, and there are 3 wires coming out from the plug: the earth, the live, and the ground. So I connect the live and the live and the other one. What is that?
It's the hot, light, and ground.
Yeah, the hot and the live into this. Then I control.
So if I want to use the relay for the switch, I need 2 Arduino board to communicate with each other. Or this? There is also Wi-Fi.
No, this connects to your ESP32.
Okay.
So this acts as a switch.
The switch, if that switch is far away, so two
Ah.
Arduino communicating with each other, that's it.
I mean, if you connect both with Wi-Fi, then everything is on Wi-Fi,
So
unless
the house Wi-Fi.
yeah, you use the house Wi-Fi. Be cautious that when you want to do a smart home with enclosed switch like that one, you have to open it, do a circuitry,
So I
which is
need a
dangerous.
Wi-Fi that can connect 30 devices or more.
That could be done. And this small little thing can connect 32 devices, which is all of you, plus all of your PC and all of your ESP lah.
This one, for your fan, how did you connect, what about, that one was 230 volts or?
Yeah, because this relay is 5 volt controlling 250 volt. This little thing.
What about the ampere? It was okay.
The ampere maximum is 10 amp.
10 amp.
10 amp. 10 ampere.
The speed was different, right? When you were controlling, it was less.
I didn't remember what was happening. I know that it successfully on. This has its own limitation, but I don't think it can connect up to aircon level lah. But for fan and lights, why not? So that's one application. Any more suggestions, comments, questions? Good. So now we will do LED. Now we are going to advanced, you know. We are doing advanced programming. First is LED dimming or changing LED brightness. So the way we do that is, it's actually a concept called PWM. Anyone heard about PWM? Pulse width modulation. Sorry. So PWM means, I mean, all our pins is either 3.3 or 0. Okay? 3.3 is the maximum brightness, 0 is no brightness. But if you can somehow change the way that the signal is being sent, you can create an average value of different voltage. For example, if it's a sine wave, right, and you say if this is 5, you usually calculate the average, which is around here. The average voltage for an AC current. The same goes to the PWM, which instead of keep supplying the 3.3 volts to the LED, you are supplying a square wave. And depending on the frequency or the width, you get different average. For example, this average is 2. And you get equivalent brightness of 2 volts, which is a bit dimmer. Okay. So we shall now do that. I mean, if you seriously ask me, I don't know the details. Should ask an EE student. So let's go back to this. And I shall create a new sketch. New sketch. The way we call and changing brightness LED is using LED C write, which is a special command to control LED brightness. So I've already prepared a code for you, and we're gonna copy it together. So here you can might as well download it. It's called the LED brightness. It's called this download. And later we're gonna incorporate this into our IoT cloud. And we will learn how to modify the code again. Okay. So this is the code. For the sake of this demo, I will write it again for you. You don't have to do all this, but you will do this. I was talking about frequency, right? The frequency that determines this one. But this one is a bit technical, and we will just adopt the default value given. So let's write before the void setup. That says this constant integer frequency equals to 5000. Do you know what does the const mean? CONST? Any idea? Constant, yeah. Constant means you can't change. So this is not valid. If you suddenly do, okay, frequency equals to 100, it returns you an error. Because you already specify that it's a constant and you shouldn't change the value. Okay? So constant integer frequency is 5000, and we do LED channel integer constant integer LED channel equals to 0. Constant integer resolution equals to 8. So now we do the LED control setup. LED C setup. That's your LED control setup. And put in your LED channel. Put in your frequency. Put in your resolution. Put your semicolon. And the next thing we'll do attach. And I made a mistake here, should be a uppercase S. LED C attach pin. I'm attaching the LED pin to number 4 and the LED channel remain. Okay. So we're done with all the setup. We can start to loop. So now you can see, if you want to control brightness, you can write LED C right, LED channel. And the next thing is the value that you give. So by default, the value accepts 0 to 255. 255 being the brightest, 0 being the dimmest, right? 0 means nothing, 0 volt. You can do the math to calculate what's the voltage for 100, let's say. So I'm gonna put 100, for example. And then upload. Okay. ESP32. By now, you should be an expert of uploading code, and you should be an expert of troubleshooting. So in the case of not getting value or anything, please. I couldn't see if my LED is on 100 brightness or not. So I'll do a blinking, but instead of blinking on and off, I shall blink bright and dim, right? LED C right, my channel, make it brighter to 55. So my LED should blinking alternately between low brightness and higher brightness. Which successful. Yeah. Okay. No, oh, didn't put a delay. So you see a different brightness for your LED? See? The brightness is now changing. Slightly. So give you some minutes to change your LED brightness. And analogRead works for Arduino. ESP32 doesn't work. Have to use something else. Why? Because the clock is different. The chip. Arduino use Mega328, but ESP32 use something else. So different chip got different function. You ask me in detail, I cannot tell you. So you have to read also. Okay. Okay.
Okay.
Good.
Can I see the last line?
The what? Oh, let me just copy this and put in Google. Here. Okay. Yep. Okay. Troubleshooting? No.
The LED channel 100 and 255 means is the brightness, is it?
Yep.
So how can I know the range?
The range,
Yeah, from what to what?
the range require you to do some mathematical calculation. You really want to know? Okay. Might be a bit boring. Okay, I'll try. So, okay. This is a square wave. So you have a period just like your period of sine is from node to node. So this period is also from here to here. Okay, so this is the P. And your F is 1 over P lah. Okay. Frequency equals to 1 over period. So you have another thing called the duty cycle. Duty cycle. So duty cycle is the percentage of on state in a whole period. So for example, this one on for 5 milliseconds and off for 5 milliseconds. And the duty cycle will be 50%. Because you take the on divided by the total times 100%. Okay. Another type of wave will be a very short on and longer off. So it looks like this. So this one is maybe 1 millisecond on and 9 millisecond off. So the duty cycle will be, can I calculate?
10%.
10%.
Yeah.
So that's the duty cycle. And this is the frequency, FREQ. So first, the LED channel means how, okay, in the ESP32, you can do 16 PWM at the same time. Different channel. So from 0 to 16. Since this is the very first PWM we use, we do 0. Okay. So you try to take frequency divided by resolution, see what you get. I don't have a calculator. Actually, I have a calculator.
635.
Ah. So just now this duty cycle, right? We write it here. Okay. But not in percentage lah.